For section 4.5, we're still going to talk about triangle congruence, but now we're going to add in angle, side angle, 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 side, and hypotenuse leg theorems. So we are going to start off here with a vocab word that's included side, and that is the common side of two consecutive angles in a polygon. So in other words, they share. This included side is included in two angles. So as you can see over here in the picture, segment C is part of angle A and it's part of angle B. So that included side kind of helps us with the angle side angle postulate here. And it says if two angles and the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. So as you can see here, we have angle A, then we have the side marked with the tick mark, and then we have angle C that's congruent to D here, angle D, and then this side, and then angle F. So if we go around this triangle, we have an angle, a side, and then an angle here. So for an example 1 here, we have to determine if you can use angle side angle to prove that triangle UVX is congruent to triangle WVX and explain. So we're shown here that angle UXV, which is this one right here, is congruent to this angle over here, which would be angle VXW, and that is given by that picture. And we also know that this angle here, WVX, is a 90-degree angle, and it is forming a straight line with the angle over here. So angle WVX is congruent to angle UVX. Those two angles are a linear pair. And then that's an angle. And then we talked about the other angle up there at the top at point X. We can see that this line here is shared with both triangles. So segment XV is congruent to segment XV. It's the same segment because of that reflexive property. And therefore we have an angle, then we have a side, and then we have another angle. So triangle UVX is congruent to triangle WVX because of the angle side angle theorem. Next, we have angle angle side, and that is if we have two angles and a non-included side. So if we're going around the triangle, we start here, we have an angle, then we have another angle, and then we have a side. If we have that on two triangles, that proves that they are congruent. So angle, angle, side. So example 3, it says use angle, angle, side to prove the triangles are congruent. So we're given that AB is parallel to ED and BC is congruent to DC. So the arrows are showing parallel, and the tick mark is showing congruence. All right, so always write down our givens. And then if we look, if we pretend these lines are, oh, that's terrible. Try that again. These lines are extended, and we can look here, we have angle B and angle D there. Those are going to be congruent angles because they are alternate interior. So they're on opposite sides of the transversal and they're on the inside of our parallel lines. So those are alternate interior angles. Oops. That was a theorem. And then we can also say angle A and angle E are congruent because of they're also alternate interior. They're on a different transversal that's cutting through those parallel lines, but they're still on opposite sides of the transversal and on the inside of our parallel lines. So angle A is congruent to angle E because of alternate interior angle theorem again. And then if we look, we have angle, then we have another angle, and then we have a side. So we can prove that triangle ABC is congruent to triangle EDC by angle, angle, side. And then lastly, we have what's called the hypotenuse leg congruence theorem. And that says if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. So in our diagram here, remember the hypotenuse is the longest side, and a leg is one of the shorter sides. So the hypotenuse is labeled with the 2 tick marks, and then the leg is labeled there with 1 tick mark. So that proves that those triangles are congruent. So for example 3, we're going to look at this picture, and it says determine if you can use the HL congruence theorem to prove the triangles are congruent. If not, tell what else you need to know. Okay, so we are going to look at the 2 larger right triangles here. And it's given that angle V is congruent to angle Y. That's showing that those are right angles. And then it's also shown here that segment WV is congruent to segment YX. So those 2 things are given. So we have the leg is congruent, and to use the hypotenuse leg congruence theorem, we need to prove that the hypotenuses are the same. So the hypotenuse is always the longest side of the triangle, and it's always opposite of your 90-degree angle. So as you can see here, this hypotenuse, both triangles share the same hypotenuse. So segment WX is congruent to segment WX because of that reflexive property. Reflexive property. If they're the same segment, then that's the reflexive property. And so I can put 2 tick marks there. So now we have proved that the hypotenuse was the same, and we were given that the leg was the same. So now we can say that triangle WVX is congruent to triangle XYW because of the hypotenuse leg congruence theorem. Now, what if we looked at the 2 smaller triangles? So I'm going to erase all the writing I did there. And we're going to look at these little guys. There. So we're given that angle V is congruent to angle Y. They're both 90-degree angles. And we're also given that segment WV is congruent to segment YX. So the only thing, we have a leg. So remember, this is the hypotenuse across from the 90-degree angle. And we don't have any way of proving that they're the same. We don't know anything about that triangle that's underneath of them, any angle measures, any side lengths. So we are unable to prove, even though our picture looks like they're the same, we cannot prove that their hypotenuses are the same. And remember, if we can't prove it, then it isn't true here. We can't just go by looks in the picture.